Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, Houston, we don't have a problem. Today we want to talk about inclined planes. Now, an inclined plane is, well, a plane that's inclined. So we've got, these are going to be types of problems. Let's say that we've got a car that's on a ramp. That's the inclined plane. You know, it's a car. And maybe it's going up the ramp. And the trick on this is that it's going to have an angle. We'll call this angle theta. And the question is what's going to cause the car to go basically up or down? And the big question is all about its acceleration. Now on the Earth, we know the acceleration of gravity is 9.8 meters per second squared, right? That is not actually technically negative. It's not true on an inclined plane. It'll be a portion of 9.8. Because, well, it's probably best to think about it. Let's draw an inclined plane, because it's actually a geometry problem. I'll draw a little bit bigger so we can have a little bigger one. So we've got an inclined plane. Let's say it's like this. And let's say the angle here, what would be the angle on this one? Let's say this is a 40-degree angle. And I've got an object. I'm just going to make it a block right here. We're going to assume sort of a frictionless surface, though. And if this is 40 degrees, gravity always points down, directly down. And what we can do is we could draw another triangle that's going to look like this. And it turns out this 40 degrees is also equal to this 40 degrees. Okay? And so the acceleration is only this component, if you will, of this triangle. Right? You've also got the component that's directed downward. But if you think about this, if this is 40 degrees, and if we know what, how do I say this? The downward is 9.8. So this is 9.8. And so if this is the, and 9.8 is the hypotenuse of this triangle. Sorry, that's the hypotenuse. And so the acceleration is this component here. And so since this is these 40 and this is the opposite and the hypotenuse, that's from SO and SOHCAHTOA. So it turns out the acceleration in an inclined plane, the acceleration is going to be g times the sine of theta. So in this particular case, assuming we're on the Earth, it'll be 9.8 times the sine of 40 degrees. So in this particular example, calculator here. I'll take 9.8 sine of 40 degrees, and I get 6.3 meters per second squared. So at a 40-degree angle, instead of 9.8, I have 6.3, and actually it would be negative. Now, a couple things on these kinds of problems that you want to watch. I've just said, well, it's 40 degrees. I may not always give you 40 degrees. I may give you the ramp is this wide and this tall. So if you know it's this wide or this long and this tall, you can find the 40 degrees, right? Or I may say that the length of the ramp is, 80 meters. I'm giving you the hypotenuse and maybe also give you the height. A ramp extends for 80 meters with a height of 40 meters. If this is 80 and this is 40, then you're going to have to use some trigonometry, right, to do that, right? If let's say it's 80 and 40, let's just say for the sake of argument. What would be the angle of the ramp? Well, that's the opposite and the adjacent hypotenuse. So that'll be sine of theta equals opposite 40 over 80. Now on your calculator, if you recall, the way to do that is I use the inverse tan or sine function, and I'll say of 40 divided by 80, or really it's a half, isn't it? And I get 30 degrees. So if it was this case, theta would be 30 degrees if you had 40 and 80. 80 is the hypotenuse. And that would be a 30-degree angle. So once you've done inclined plane, so inclined planes sound like horrible, but the only thing that changes in an inclined plane is the acceleration. And it's going to be some number less than the g on the planet you're on the Earth. It's going to be a little bit less than, sometime less than, it might be a lot less if at a less steep angle, because the only g that matters is, or the acceleration that matters is this sine theta that's going down. And otherwise, these problems are not ugly. We'll do in the next video just a problem or two to make sure you understand how to do this. But the big idea for inclined planes is the acceleration is not 9.8 anymore. It's just g sine theta. And once you know that, you can then solve the other problems you're going to see, the kinematics problems, using the 3 key kinematics equations that we've learned in previous videos. Houston, we don't have a problem.